Tesla's aluminum-ion battery revolution emerges as a milestone that transcends engineering and touches the very imagination of the future, uniting absolute safety, extreme charging speed, and almost mythological longevity in a single energy solution. In the analyzed video, this technology appears not as a simple evolution of current batteries, but as an evolutionary leap that redefines the paradigm of electric vehicles, breaks global dependencies, and opens a new frontier of innovation where efficiency, sustainability, and resilience converge. The feeling is that we are witnessing the genesis of an era in which energy ceases to be a limiting factor and becomes an element of technological freedom. The promise of maximum safety transforms the aluminum battery into a silent protagonist in a world where fires, explosions, and thermal instabilities become memories of the past. By completely abandoning the flammable elements typical of lithium batteries, this new solution structurally eliminates the risk of uncontrolled reaction, even in severe collisions. In the video, it becomes clear that this characteristic is not a technical detail, but a watershed moment that redefines the value of protecting the user, occupants, and even urban infrastructure. For the first time, we drive not only efficiently, but with complete peace of mind. The extreme durability highlighted in Tesla's design reveals a philosophy distinct from any other company in the sector. The battery ceases to be a disposable component and becomes a lifelong asset, with more than 15,000 recharge cycles and an accumulated range of millions of miles. This scale of longevity surpasses any traditional expectation of automotive lifespan and creates a new economic model where the car, instead of depreciating rapidly, acquires value by withstanding the test of time. This change alters the logic of consumption and opens space for a more robust and sustainable used car market. The abundance of aluminum, repeatedly highlighted in the video, is another point that confirms Tesla's visionary strategy in breaking critical dependencies on lithium and cobalt. These materials, increasingly expensive, rare, and concentrated in a few countries, have transformed the battery industry into an unstable geopolitical field. With aluminum, everything changes. It is an element present on a large scale on almost every continent, easy to recycle, low cost, and extremely versatile. Tesla's choice is not only technological but geostrategic, a calculated step towards energy sovereignty. The innovative design based on a three-dimensional honeycomb-shaped cathode is presented in the video as more than just an aesthetic curiosity. It's a triumph of engineering inspired by nature. This geometry increases the surface area by up to 5 times, allowing aluminum ions to move more efficiently, reducing internal resistance, improving flow, and increasing thermal stability. The honeycomb, a symbol of precision and natural collaboration, now becomes a metaphor for energy efficiency applied to modern mobility. In a direct comparison with lithium batteries, the video's content reveals an almost uncomfortable contrast. While aluminum operates safely even at temperatures close to 250 degrees Celsius, current batteries struggle to maintain integrity above 125 degrees. While dendrite formation simply doesn't exist in aluminum, lithium models coexist with this metallic ghost that causes short circuits, multi-million-dollar recalls, and life-threatening risks. The comparison makes it clear that we are witnessing not market competition, but the inevitable replacement of one technology by another. The behavior of the aluminum battery in collisions is another crucial detail that the video powerfully highlights. In impact situations, while lithium batteries generate chain reactions capable of intensifying damage, the non-flammable electrolytic gel of aluminum remains stable, absorbing energy without generating additional risks. This not only improves vehicle safety, but directly alters insurance projections, rescue protocols, and even how cities plan for the mass adoption of electric cars. The practical benefits for the user go beyond the technical sphere and reach the everyday experience. The possibility of recharging up to 80% of the battery in just 3 minutes and reaching a full charge in less than 5 completely transforms the refueling ritual. This speed brings the use of electric vehicles closer to the familiarity of combustion engine vehicles, but with all the environmental and mechanical advantages of electric systems. In the video, it is possible to feel the emotional impact of this change, almost as if we were witnessing the rebirth of modern mobility. The resistance to extreme heat, so highlighted in the presentation, redefines the geography of efficient electric vehicle use. Regions like Texas, Arizona, the Middle East, and parts of Brazil, historically challenging for lithium batteries due to intense heat, become natural territories for aluminum technology. This means that the future of electric vehicles is no longer concentrated in temperate climates but becomes a truly global solution, without environmental limitations. Reduced maintenance is another direct consequence of this clean and stable engineering. With no need for complex cooling systems, no risk of thermal degradation, no dendrites, and an extended lifespan, the cost of ownership plummets. The video highlights that the battery hardly wears out, allowing for savings that even surpass the maintenance costs of high-performance electric bicycles. Tesla doesn't just build a product. It builds a new economic logic that benefits the consumer in an unprecedented way. The environmental dimension is treated in the video not as a secondary detail, but as a central piece of the impact of aluminum technology. The long lifespan reduces the need for large-scale production, which drastically decreases the consumption of natural resources, CO2 emissions, and the disposal of electronic waste. The choice of a fully recyclable material reinforces a sustainable cycle where each battery can be reborn countless times, reducing pressure on nature and extending the lifespan of the technological ecosystem. The sustainability of the production chain is a powerful structural advantage, clearly highlighted. Aluminum does not suffer from supply bottlenecks, does not depend on unstable political regimes, and does not require mining operations with high social or environmental risks. Logistical simplicity creates a fairer, safer, and more balanced scenario for the entire global chain. In the video, it is evident that Tesla is not just building batteries, it is breaking with outdated industrial models and proposing a new ethic of energy production. The impact on the resale value of vehicles is another transformative point. Cars equipped with this battery will not suffer accelerated depreciation, as the battery, traditionally the component that ages the most, will maintain its integrity for decades. This alters the consumer's relationship with the vehicle, which ceases to be a purchase with an expiration date and becomes a long-term investment. The video highlights that this durability creates a positive ripple effect in the used car market, in auto credit, and even in public perceptions of value. The pressure on competitors is inevitably intensifying, creating a technological race that forces other automakers to abandon traditional models. The aluminum battery redefines the minimum acceptable standard for safety, speed, and durability. Companies that fail to keep pace may quickly lose relevance. The video suggests a scenario in which Tesla assumes an almost uncontested leadership position, forcing a global adaptation in a sector accustomed to slow evolution. The timeline presented in the video reinforces the contrast between the problematic past of lithium batteries and the promising future of aluminum. In 2022, massive recalls in the United States involved more than 1 million vehicles due to the fire risk of traditional batteries. The projection for 2026, with the arrival of the aluminum battery, symbolically marks the end of this unstable era and the beginning of a new phase of total safety. The even more ambitious future includes the application of this technology in electric aircraft, residential systems, and large-scale infrastructure. The prospect of adoption in used vehicles is particularly fascinating. With such a long lifespan, a single battery could serve multiple generations of cars, drastically reducing the cost of electrifying popular fleets. The video describes this as an energy democratization, where even simpler vehicles can benefit from cutting-edge technology without increasing production or maintenance costs. The use of aluminum in residential energy storage systems is presented as one of the pillars of future expansion. Its thermal stability, absolute safety, and low cost make aluminum ideal for homes, buildings, and even small cities. This adaptation will create a more resilient, decentralized, and fossil fuel-independent energy grid, allowing for greater autonomy for entire communities. The possibility of using aluminum in electric aviation is perhaps the most ambitious and futuristic vision in the video. Fire safety, tolerance to extreme temperatures, and stable energy density make aluminum an ideal candidate for medium-range aircraft. Tesla indicates that this is a long-term goal, but perfectly plausible within the technological window projected for the coming decades. The elimination of dendrite formation is a monumental technical achievement that the video highlights with dramatic emphasis. These metallic crystals, responsible for short circuits and catastrophic failures in lithium batteries, simply do not appear in aluminum. This absence eliminates one of the main points of wear, risk, and cost of current batteries. By overcoming this problem, Tesla achieves a level of reliability that seemed unattainable just a few years ago. The ionic efficiency provided by the honeycomb structure revolutionizes battery behavior during intensive use. In high-demand scenarios, such as rapid acceleration, uphill climbs, or heavy loads, the battery responds with thermal stability and minimal efficiency loss. This characteristic brings aluminum closer to sports or industrial applications, creating a new universe of possibilities for trucks, high-performance SUVs, and utility vehicles. The non-flammable gel electrolyte reinforces the battery's structural robustness and transforms the concept of passive safety. Even in the event of puncture, crushing, or severe damage, the material does not react violently, does not evaporate, and does not combust. This characteristic virtually eliminates risks in accidents and increases user confidence in dense urban environments and dangerous roads. The ability to withstand temperatures up to 250 degrees Celsius completely changes the game in industrial applications. Mining machines, off-road vehicles, oil platforms, agricultural tractors, and autonomous cars will be able to operate in regions where current batteries would fail in minutes. This resilience elevates the aluminum battery to a level of versatility unprecedented in the history of electrification. The promise of a full recharge in up to 5 minutes is possibly the most impressive point of the video, as it represents the dissolution of the last psychological obstacle that separated electric vehicles from fossil fuels. The user parks, connects the cable, waits a few moments, and continues their journey with a full battery. This natural flow eliminates anxiety about time and creates an experience that completely redefines the public's relationship with electric mobility. The chemical stability of aluminum prevents accelerated degradation, even in repeated ultra-fast charging cycles. In the video, experts explain that, unlike lithium, aluminum does not undergo significant thermal expansion, does not break internal structures, and does not lose efficiency over time. This consistency allows for aggressive charging without compromising lifespan, creating a balance rarely seen in energy technologies. The absence of complex cooling systems represents a silent but powerful revolution. Without additional pumps, sensors, pipes, and radiators, the vehicle becomes lighter, cheaper, and easier to maintain. The video highlights that this simplicity removes several common failure points in current EVs, increasing the overall reliability of the electrical system. The impact on auto insurance is another surprising point revealed in the video. With no risk of fire, no chain reactions, and a virtually indestructible battery, insurance companies should reduce prices, further facilitating mass adoption. This creates a positive circular economy for consumers, manufacturers, and regulatory authorities. Exceptional durability opens doors to new business models, such as long-term leasing, commercial reuse, and integration with autonomous fleets. Vehicles with immortal batteries become highly valuable financial assets, with increasing returns over time. The video suggests that this feature could revolutionize urban transportation and logistics. The combined total range of millions of miles elevates the battery's value to an almost symbolic level. We're not just talking about mechanical durability, but about a component capable of spanning generations of automotive technology. The battery ceases to be just part of the car and becomes part of the user's energy lifespan, a constant that permeates different machines. The ease of aluminum production reduces industrial costs, speeds up assembly lines, and decreases dependence on complex chemical processes. The video shows that this not only simplifies manufacturing, but also allows for unprecedented global production scaling, meeting the needs of millions of vehicles per year with stability. The three-dimensional honeycomb structure dramatically increases heat dissipation, making the battery naturally self-generating. This allows for greater energy density without compromising safety, something that seemed impossible to achieve decades ago. The biomimetic engineering applied in this design marks a milestone in the fusion of nature and technology. The lightness of aluminum directly benefits aerodynamics, energy consumption, and overall vehicle performance. A lighter EV accelerates faster, consumes less fuel, and experiences less wear and tear on components like tires and brakes. This synergy creates a chain of advantages that multiply the benefits of the battery. Stability in humid and tropical environments creates new opportunities in countries in Latin America, Asia, and Africa. Unpredictable lithium behavior in hot and humid environments ceases to be a problem, allowing the expansion of EVs into emerging markets where there was previously resistance due to climate issues. Natural compatibility with solar and wind systems transforms aluminum into a key element for 100% renewable electricity grids. The video points out that this technology will allow homes, neighborhoods, and even cities to be powered by clean energy with stability and minimal cost, ushering in a new era of energy independence. The social impact of mass adoption is profound. Fewer garage fires, less toxic smoke poisoning, fewer deaths caused by explosions, fewer recalls, and greater confidence in public infrastructure. Technology creates a safer urban and home environment, with direct consequences for collective well-being. Extreme durability drastically reduces the need for constant recycling. Instead of discarding millions of batteries per year, society will live with components that last for decades. This reduces pressure on landfills, mining operations, and recycling systems, generating a lasting positive environmental impact. The absence of cobalt eliminates ethical problems related to mining in vulnerable regions. This brings Tesla closer to a cleaner, fairer, and more humane industrial future. The video highlights the importance of technologies that do not exploit conflict zones or precarious labor. The economic viability of batteries creates space for much cheaper EVs, accelerating the energy transition. With lower costs and greater durability, the technology makes electric vehicles accessible not only to middle classes, but to wider populations, democratizing clean mobility. Ultra-fast charging becomes especially useful for autonomous fleets and robo-taxis, which need to remain active almost 24 hours a day. This efficiency transforms urban logistics and reduces operating costs for transport and delivery companies. Compatibility with existing charging infrastructure means the transition will be quick and cost-effective. There's no need to rebuild entire networks. Simply upgrading systems to support higher speeds is sufficient. This relatively simple adaptation accelerates global adoption. The video highlights the battery's robustness during long periods of inactivity. Even after months of disuse, the aluminum retains its charge without significant loss, which benefits users who use their car occasionally, as well as stationary backup systems. The application of portable micro-power cubes could transform the electronics, drone, robotics, and medical equipment industries. Its absolute safety makes aluminum ideal for hospitals, aircraft, space missions, and sensitive devices. Aluminum creates new opportunities for rural energy, powering tractors, irrigation systems, and heavy machinery in remote regions without the risk of combustion, even in extreme heat. This benefits modern agriculture and increases overall productivity. Independent cooling systems eliminate common noise, vibrations, and malfunctions, creating quieter, more comfortable, and longer-lasting vehicles. The video highlights that this improvement enhances the sensory experience for users. Chemical stability allows the battery to survive thousands of cycles without significant capacity loss, creating a nearly horizontal degradation curve.